Welcome again to problems in construction management, and today we're going to talk about some PDM solved examples, presence diagramming method, as we have discussed it in the previous lecture. So let's have a quick look at this example here. Very simple problem. As you can see, the activities are represented by boxes. Each box has the name of the activity and its duration, and then we have the links or the relationships between the activities. Some of them are traditional finish to start with no lag or overlap, like here. Some of them are start to start with lag. Some of them are finish to start with overlap, which is a negative lag, and so on. Now we're going to assume contiguous duration for the activity, which means once the activity starts, it should keep going without any interruption. As you may notice here in this network, we have activity B with an open end from the finish side. So we're going to see how does that affect the calculations. Now, starting the calculations, we're going to start from the start side of the activity A, which is the absolute left of the network. And as we assume, the network is going to start on day 0. So it's going to start on day 0, and as the duration is 12, then it's going to end on day 12. Looking at the activities B, C, and D, they have a finish to start relationship with activity A. So all of these activities are going to start on day 12. And with their respective durations, activity B has 8 days, so it's going to finish on day 20. Activity C, 15 days, ending on day 27. And activity D, 14 days, ending on day 26. Now, looking at the following activities, activity E has only one immediate predecessor, which is B. So from B, we're going to take the 12. To get the start of activity E, it's a relationship of start to start, but it has 4 days of lag. Therefore, the start of activity E is going to be 12 plus 4 days of lag here, which is going to be 16, with a duration of 11. It's going to end on day 27. For activity F, it has one immediate predecessor C, finish to start, with 2 days of overlap, which is the negative lag here, which means activity F is going to start 2 days before the completion of activity C. Therefore, the expected start for F is going to be 27 plus negative 2, which is 27 minus 2, that's 25. Its duration is 7 days, so it's going to be expected to finish on day 32. Activity G has only one immediate predecessor, D, finish to start, no lag, no overlap, therefore it's going to start on day 26. With a duration of 10 days, it's going to end on day 36. Going to activity H, it has two immediate predecessors, E and F, and the dates coming from E are 27 and from F 32. This is the forward pass, we're moving forward, therefore we're going to take the larger of the two numbers. So for the start of activity H is going to be day 32, with a duration of 16, is going to end on day 48. Activity I also has two immediate predecessors. But it's quite interesting here because the immediate predecessors link at two different locations. So let's look at the dates coming to the start of I from these two respective activities. From F, we have 32, no lag, no overlap. So if it had only F as a predecessor, it should start on day 32. But it has another predecessor, which is G. We notice that the relationship with G is finish to finish. Look at the connecting points on the relationship. Finish to finish with 5 days of lag, which means I should finish 5 days after the completion of G. Now let's calculate the two dates going to the start and the finish of this activity. If we were going to use 32 from F, it would be 32 at the start plus 18, that would give 50 at the end of activity I. If we were to take only activity G, it would be 36 plus 5, that would be 41. So the larger of two numbers comes from activity F. Therefore, we can say that activity F is the one that drives activity I. Therefore, we're going to take the 32 plus 18, that's 50. Now, looking at activity J, the last activity in the network, we have two immediate predecessors with the numbers 48 and 50 coming from H and I respectively. We're going to take the larger number since we are still in the forward pass. so it's going to be 50 plus 9, and the early finish of this network is day 59. Now we are done with the forward pass. Again, what did we do in the forward pass? We moved from left to right, adding the durations, adding the lags, and adding the overlaps, basically plus -2. If you notice what I said here, plus -2, which is the same as -2. So we just keep moving from left to right, adding the durations and the lags and the overlaps until we reach the end of the network, and that gives the early finish of the network. Now we're going to start the trip backwards. So we're going to start from the end of activity J, and the early finish is 59. It's going to be the same as the late finish. So we're going to drop here 59 minus 9. Now we're moving backwards, so we're going to subtract, which gives 50 at the late start of activity J. The first thing to notice is that the early start and the late start are exactly the same. The early finish and the late finish are the same. Therefore, what's the total float of activity J? Basically, it's 0, which means activity J is critical. And this is something that we can conclude and we can expect. Usually in a network like this, starting with one activity and ending with one activity, usually the first and the last activities are going to be critical, since there's going to be one continuous path linking these two activities from beginning to end. Therefore, they're going to fall on that critical path, or that longest path in the network. Now we have to move back and see which other activities are going to be critical and where's the critical path going to be. So this 50 is going to be transferred basically to the finish of activity H and the finish of activity I, and then we're going to subtract the durations, and we have here 50 minus 16, that's 34 at the late start of H, and 50 minus 18, that's 32 at the late start of I. We notice again for activity I, the dates are exactly the same at both sides. So early start, early finish and late finish, the early and late dates are pretty much the same. Therefore, this is another critical activity. But looking at activity H, we notice that the late finish is different from the early finish, and the late start is different from the early start, which means this is going to be what we call the total float. Total float is late minus early, either from the start or the finish for the time being. So late finish minus early finish, or late start minus early start. So the total float for activity H is going to be 2 days. Now, remember the Saad method that I told you about when we try to calculate the free float of activity H. We said that the free float of an activity is going to be its total float minus the total float of its immediate successor, or the largest total float of any of its immediate successors if it has more than one immediate successor. So looking here, this is an activity that has 2 days of total float with only one immediate successor, which has 0 days of total float. Therefore, the free float for activity H is going to be exactly the same as its total float, which is also equal to 2 days. Activity I, of course, since it's critical, and by default any critical activity has 0 total float and 0 free float as well. Now let's move back, going to, for example, activity E. We're going to find that it has only one immediate successor. Therefore, that 34 is going to be transferred here as is, because there's no lag or overlap. And for activity F, which has 2 immediate successors, we have 34 coming from H, 32 coming from I. Remember, this is the backward pass, so we take the smaller number. Therefore, we're going to take here the 32. So let's look at the numbers. Here, for example, we have 50 minus 5, which is the lag, so it's going to end on day 45, minus the duration 10 is going to start on day 35. And here we have the 32, which is the smaller of the two numbers, 32 and 34. 32 minus 7, that's 25. And here we're going to have 34 and 23. 34 minus 11, that's 23. As you notice, we are moving one column at a time. We're not moving to the whole beginning of the network. We're taking it one column at a time. Alright, now if we move back to activity D, for example, it has only one immediate successor. So the 35, no lag, no overlap. 35 is going to be transferred here as is, minus 14, that's going to be 21. Activity C has only one immediate successor, 25, minus negative 2, because now we're moving backwards, so we're subtracting, minus negative 2, which means plus 2, therefore this is going to be 27 and 12, and as you can notice here, as expected, the critical path so far is J, I, F, C, and we had agreed beforehand that A definitely is going to be critical, so we're going to see that in a second. Let's now move to activity B. We have 23 at the start of activity H. The relationship is start to start, correct? But with a lag of 4, so it's 23 minus 4, which makes this 19. 19 plus 8 gives 27. 19 plus 8 is 27. So basically that's how we calculated the late finish of activity B. It came in reverse. We had to calculate the late start first, and then we add the duration to get the late finish. So here it has 7 days of total float. Now going back to activity A, the least of the three numbers, 19, 12 and 21, is going to be the 12. Actually this is 12 minus 12 is 0. Therefore here's my critical path, A, C, F, I, J. We can also calculate the floats. So for the activities that are non-critical, activity D, for example, it has a total float of 35 minus 26, or 21 minus 12, which is 9. The immediate successor G has also 9 days of total float. Therefore the free float for activity D is total float of D, which is 9, minus total float of its successor, which is also 9. Therefore the free float for activity D is 0. Now for activity G, it has a total float of 9 days, and its immediate successor is critical. Therefore the free float of activity G is going to be exactly the same as its total float, which is also 9 days. Going to activity H, we have already agreed that it has a total float of 2 and also a free float of 2. Going to activity E, it has a total float of 7, which is 34 minus 27, or 23 minus 16. Its total float is 7. The total float of its immediate successor is 2. Therefore the free float for E is 5 days. Activity B, total float also 7. 19 minus 12, or 27 minus 20. The total float of its immediate successor is also 7. Therefore the free float for activity B is 0. And that's basically how we do the calculations for a PDM simple network. Let's look at another example which is going to enforce our understanding of these calculations. Here we have a very similar network as well. So we have here finish to start with an overlap, finish to finish with lag, finish to finish with lag, finish to finish with lag, finish to start with overlap, start to start with lag, and finish to start with no lags, no overlaps. So activity A, we're going to move faster this time. Activity A, 0 and 11. B is going to be 11 and 24. C, 11 plus negative 3, so it's going to be 8 and 23. D is going to be 11 plus 8, that's 19, plus 14, that's 33. E has two immediate predecessors. We have 24 coming from B, 23 coming from C. Forward pass, we take the larger number, so here is going to be 24 plus 9, that's 33. Activity F has one immediate predecessor, C, but the relationship is finish to finish with 7 days of lag, so it's going to be 23 plus 7, that's 30, but remember the 30 is going to come at the finish side, so assuming again that it's contiguous, therefore it has to start on day 20, so it's going to be 20 and 30. Going to activity G, it has two immediate predecessors. Similar to the previous problem, these predecessors come at two different points. Here we have from D is going to be 33 plus 6, that's 39, minus 9, which gives 30 at the beginning. But here from E we have 33 plus negative 2, which gives 31, larger than the 30, so E is driving G, therefore it's going to be 31 and 9 is 40. Activity H is going to be, here we have again 33 and 30, we're going to take the larger number, the 33 plus 8, 41. Again, looking at activity I, we have numbers coming from both sides. If we look at G, it's going to be 40 plus 12, that's 52. If we look at H, it's going to be 41 plus 9, that's 50 at the end. So at the end we have from G 52, from H 50, we're going to take the larger number. So here we're going to have 40 and 52. That's the forward pass. Very simple, very straightforward. We add the numbers as we are moving from left to right. Now starting the backward pass, again, the late finish is going to be the same as the early finish, so it's going to be 52 minus 12, that's 40. Again, network starts with one activity, ends with one activity. We should expect the first and the last activities to be on the critical path. Now think about it for a second. Where is the longest path? Which path gives the largest numbers? Someone might get confused and say, well, H is 41 and G is 40, so H is longer. No, that's a trick, because H goes to the end, but G goes to the beginning, and we found out that G is the one that drives I, therefore G must be the one that's critical. So it's going to be, here we're going to have 52 minus 9, that's 43, minus 8, 35, and here we're going to have, if we follow that same path, here we have the 40 and the 31. Now going to activity E, we have, what's the number coming to E from G and H? From H, what do we have? We have 35. From G, what do we have? 31? No, it's 31 minus negative 2, which is 31 plus 2, therefore it's 33. So 33 from G and 35 from H. This is backward pass. We take the smaller number, so we're going to take the 33 minus 9, that's 24. So obviously the critical path is going to be I, G, E, and then tracing backward, we're not sure yet whether it's going to be B or C. We're going to see in a minute. Here we're going to have 40 minus 6 going to the end. We did not take a number from the beginning because we don't have a relationship here. So 40 minus 6, that's 34, minus 14, that's 20. Now here at C we have 24 coming from E, and we have 35 minus 7, which would be a 28 coming to the end of C. We're going to take the smaller number, so here we have 24, and at B also we're going to have 24 and 13. So obviously B is going to be the critical activity. Moving back to activity A, here we have 11, and from C we have 9. Again, no, it's 9 minus negative 3, which is 9 plus 3. Therefore the number coming from C is 12, from B is 11. We take the smaller number, so it's going to be 11 and 0, and here's our critical path. Looking at the total and free floats again, for activity D, obviously we have a total float of 1. Its immediate successor is critical, so according to the SAT method, the free float for D is also 1. Activity H has a total float of 2. Immediate successor critical, therefore the free float is also 2. Activity F has total float of 2. Immediate successor has also a total float of 2, so the free float here is going to be 0. Activity C has a total float of 1. Immediate successors, 1 is critical, 1 has a total float of 2. We're going to take the largest of the total floats of the immediate successors. So 1 minus 2 gives us negative 1. We agreed before that we cannot have a negative free float. So whenever you get a negative free float, just put 0, and that would be the free float. So the free float for activity C is 0. Its total float is 1. As you can see, the calculations are not that hard at all. I hope that these two examples illustrate the calculations for PDM. The only thing that you have to pay attention to is where are the relationship points starting and finishing. Is it a finish to start? Is it a start to start? Is it a finish to finish? Do we have any lags? Do we have an overlaps? And how are these going to be factored in our calculations? And again, apart from that, it's just very simple math. One of the very common mistakes that I usually see on assignments and on exams is errors in that very simple math, like 19 plus 14 equals 34 or 35 or something like that. Take your time with these initial calculations, because this is what makes most of the mistakes on these problems. The math, as you can see, is very simple and very straightforward. I'll see you later in another lecture and in another example.